Hello everyone, welcome back again. My name is Jesse, and in this wonderful tutorial, we're trying to do multi-label text classification using Python. So let's understand something very simple. So we have this picture here. We have two different seasons. We have season 2, right, which is a movie for Starbeam, right, Starbeam series. And we also have tagged. So if you look at this picture, or which is taken from a website, if you are a fan of movies, you can see that this Starbeam is having 7 different labels, right, that can be used to categorize or classify this particular movie. But for the tag, this is having only one. So when it comes to multi-label text classification, we have several labels that can be used to describe one particular stuff, right, just as you are seeing in this particular image. So multi-class is just having multiple class for a particular feature, right? So one feature can either be positive, and then it cannot be positive and negative and neutral. It can only be one particular class at a time. That is multi-class classification, right? So for example, sentiment analysis, as we already learned, is a format of multi-class test classification, right? So it can be positive, negative, or neutral. It can't be the three of them. But for multi-label, just as we have in this picture here, the Starbeam can belong to animation, can belong to action, can belong to adventure, comedy, family, and then sci-fi. So in multi-labeled text classification or multi-label classification, we have one feature that can be mapped to 3 different or multiple labels, right? Multiple classes at the same time. So if you look at the S3 can belong to class 1, can belong to class 3 at the same time, as we are seeing here. So let's see how to solve this particular problem in case you have a data set that is a multi-labeled test data set. How do you solve it? So there are 3 main methods. You can transform the problem, right, into a multi-class problem, right? There are 3 different ways you can do that. You'll be trying to see that in this tutorial. Then you can also work on using adaptive algorithms, so such as KNN or random forest. These algorithms can be adopted to work with multi-labeled classification. Then the final one is to use ensemble methods, which can also help you. So these are the 3 main ways we can solve a multi-labeled text classification problem. So let's see a simple overview about the problem transformation. Very simple. So for the problem transformation, the first way we can do that is called binary relevance. In that case, we have our data here, which is our feature S, which is having 3 different classes, 3 different labels, multi-labeled. Then I'm going to pick the X feature and map it to one of my class, right? And then I'll train it like that. So I'll treat each label as a separate single classification problem, right? So I'll just pick one, train it, then I'll pick the another one, train it, and pick the another class. So the feature against one particular label, right, like that. So we are treating it as a single classification problem. The disadvantage of this is that if there is a correlation between the labels, it may be lost, right? So that is the first one, binary relevance. The next one we can also try on is with classifier chains. In that case, we have our same multi-labeled data with our S features and our 3 different classes. We can now form classifier chains, right? You can just build classifiers for each and every of them. Then so you build it for the S1, the first S feature, then the class 1. Then you get the result, right? So the result of our training will be used as the feature for the next one, right, as you can see in this picture. Then the same thing for the next one. So whatever result you're going to get is going to be added as a feature, then it's going to be used to train for the next classifier, right? That is the basic understanding behind classifier chains, so which is very useful to preserve label correlation. So that is a simple picture to help you understand it. So you just pick this first one here, right? You pick this feature, then you train it to get this result. Then you take this result that you have gotten, which is these ones, right? Then you add it as our feature. So this become X, and then this become Y1, right, which is a feature. Then you train these ones, then to get this particular result. Then you do the same thing. The result you are going to get, you add it to these ones as here to become a new set of features to train for the next one. That is a basic understanding behind classifier chains. So you are chaining them over. Then the next one we can also do is label power set. In that case, you are going to have the same data. We are going to find the unique features within them, right? You're going to transform them to give unique classes to every possible label combination, right? Then we're going to transform them into something like this, right? So it's going to have unique classes, then you're going to train it. So these are the 3 main ways for dealing with multi-label classification in case you want to transform the problem. So let's see how to do this thing in code. Okay, so let's check it out. So this is simple overview. So as we already learned, we have multi-label classification, and then the reason I'm using MIMO is like multiple inputs, right? Multiple features. It's supposed to be this option, right? It's supposed to be MIMO. MIMO is multiple input, multiple output. So most multi-label classification problems are MIMO, right? There are a lot of input, a lot of features, which is going to produce multiple output. So as we learned, you can transform the problem, you can use adapted algorithm, and can also use ensemble method. So let's check it out from code, right? So this is going to be available for you to use. So we'll be using the normal stuff that you have been doing always. So we're using pandas and then Scikit-MultiLearn. Then we also use a very nice package called Skmultilearn, right? Which is an adapted multi-learn package for classification. So let's check it out. So I'm going to load my EDA packages. So I'll be loading my EDA packages, that is pandas and NumPy. Then I also load my data visualization package, as we already do, as we always do all the time. So we will load our ML packages, right, to save us time. So we'll be using logistic regression, KNN, we'll be using decision tree, naive Bayes, and then our metrics. So we'll be importing Hamming laws to help us check with our accuracy, very useful. Then we import our packages to help us split our data set and to build features, right? Very nice. And then these are the packages that you'll be using. So we'll be using Scikit-MultiLearn. So in case you don't have it, you can just install it simply. Right, so in case you don't have, you can just go with pip install Scikit, right, multi-learn, right. That is a bit understand. That is the package that you will be trying to use. This Skmultilearn is very useful to help you do multi-label classification, right? Very simple. That is how to work with it. So let's start working with it. So I'm going to load those particular ones, and then you start working with it. So as we said, we have problem transformation. You can transform the problem into a multi-class problem, or you can use the adaptive algorithm or use the ensemble method. So these are the basic understanding in the basic ways you'll be trying to solve a problem. So let's load our data set. We're going to load our data set. It's going to be df pd.read_csv. Then I'll go into my data folder. Then we'll be using a minified data set, right? So the data set to be available for us, this is going to be SO2. That is the Stack Overflow data set, right? Something very simple. Perfect. So let's check it out. If I check this particular data set that we have, you can see that it's having a very nice way, right? You can see it in a different way. You can see that it is not just having one label, it's having multiple labels for that particular, for different tests. So as you can see, this is our title, right? And then this is our tag. So it's having different tags for one particular stuff. Then some of them is one of them I've actually cleaned them to make it simple to help us understand the concept behind it. So it can belong to MySQL, can belong to Python, can belong to PHP, right? So the 0 means that it doesn't belong to that place. The 1 means that it belongs to Python and MySQL. So if I take this particular question like this, so df.log 0, the first one, and I go with my title, you can see that this particular problem here is a question, right, which belongs to Python because it's Flask. Then it also belongs to SQL because having SQL alchemy, right? So that is something that we can do. So in this case, this is not just a single classification, it is a multi-labeled classification. So it belongs to Flask, at the same time Flask, that is Python, and at the same time MySQL. So let's see how to train this to build a multi-labeled model, right, for this. I'm just going to do a simple data type to see everything about it. It's going to be something simple that we can do. So all of them are in float. So let's convert the MySQL option. So we convert to float, right? So that everything stays the same. So it's going to be df, let's go MySQL. Don't know whether I can see it very well. Let me bring it to the top. Right here, .2 as type. Right now, cast it into float, right? So you are casting our this thing into float. That is what is called casting, right? So df MySQL I'm casting it to that, right? Perfect. Now if I go back and I check the data again, everything is working as expected. So you can actually check the value count for the entire stuff. So let's do a simple value count, right? So the simple value count for the distribution of the Python, the SQL, and the PHP. So it's going to be, let's use Seaborn to help us with that. Count plot. Then I'll go with my data set df Then I'll pass in my particular stuff. So let's pass in Python to check the proportion or the distribution or the value count of Python. So I check it out. It said Python is having about, it's not bad, right? So this is a value count. So this is how it is. So that's okay. So for Python, it is 0 and then 1. So the 1 is for Python, and then these zeros are different ones, right? That is a basic understanding. So we can also try it for the next one. We can either use this particular method here, or we can try a different method. So anyhow you want it to be, you can also try that one out. So let's check it for PHP. Right? So this is a clean data set, right? Just to help us with that, to make it simple. So for PHP, there's more, right? So I can actually use a different alternative. Instead of using the picture form, I can just go with this option, my PHP class dot value count. It's going to print it perfectly for us, and I can actually use this one to plot. So for PHP, we have 82 that belongs to PHP, and there's 62 that does not belong to PHP, right? So we can plot this one also. This is another alternative for plotting. So this is simple stuff. Dot plot. Then let's go with the kind. Plot. The kind is going to be a bar chart. A bar chart. So it's another, we can also plot it. So going to give us something similar, right? Very nice. So let's move on to do some interesting stuff. So we have seen how a data set looks like. It's actually at least almost balanced, right? So let's move on to the next step. So the next step is that we're going to be trying to do test pre-processing. Going to process our test. So we're using a simple tool to help us, using neat test to help us remove our stopwares, right, from it, right? So let's check it out. So in case you don't have it, you can just go with this option to pip install neat test to help us remove stopwares, right? It can be used to do a lot of things, but it's a test cleaning package that allows you to be able to do a lot of things. So we'll be trying to check it out. So it's going to be import neat test as nt, and then we'll be importing neat test dot functions as nfs, right? Perfect. So we'll be trying to see how to actually use it to explore data. So we explore the data for noise, right? Give their special characters. We want to try and see how our data set looks like. So I can just go with my title column. So inside my title column, that is where we have our questions, right? The questions that people are selling on Stack Overflow. Now in case I want to check for the frequency or the amount of noise, amount of depth within them, or the amount of stopwares, I can just go with the apply. I can't spell apply. Apply, right? Then I'll just go with my lambda function. So lambda s, then I'll just go with nt.testFrame, or I can just go with testFrame, right? And I'll pass in my s dot noise scan, right? You can also check the documentation for it. It's going to do a simple noise scan to scan through the data set and find the percentage of noise within them, right? The proportion of noise within them. So I can just go with my test noise. If I go with this option like this, it will analyze the data set and give us the test noise. So this is the test noise, the test length, and these things. Consider this okay. There are not a lot of noise there. Some of them are single values, so that means that there's not a lot of cleaning we are going to do. But I can also use it to explore all the various stuff there. So I can also explore some other stuff like the number of stopwares we need them, right? I can also check them out. I can extract all stopwares from it. So I can also do this option. So neat test dot, right, extractor. In case I want to extract all stopwares from it, so dot extract stopwares, right? So this is something that we can do, right? So it's going to extract all the stopwares. So these are all the various stopwares we can find within our data set, right? Some of them are not enough, so that means that we can actually clean it. So let's remove all the stopwares from our data set. So we can easily do that by going with this option. So to remove stopwares, I can just go straight away with the neat test. So if you explore neat test, right, something very simple. So if I go with this, all the methods of neat test. So if I go with neat test functions, so most of the things that we do in natural language processing is like removing stopwares, removing punctuations, all of them that you use regular expression to do, all of them are already available with this package, right? So you can actually check them out. So you can just check these things. So you can remove numbers, you can remove punctuations, you can remove stop words, you can remove special characters, you can remove all of them. So it's already there. You can remove URLs, you can remove and replace bad quotes as much as you want. So we'll be trying to use that same thing to help us remove all the stop words from that. So I can just go with NFS for neatest functions. Then I'll just go to remove stop words. So it's going to remove all the stop words for us, right? So it's something like that. So if I go with this, I'm going to analyze it and then remove all the stop words, and you can see that there are no more stop words here, right? There are no more. There are no more stop words again. So I can save this one as my corpus because this is a clean one. Then I'll use it for my analysis to make it cleaner. So I'll just come back here and call this one as my corpus, which has no stop words, right? And now let's try and see our label. So it's going to be our feature engineering. So in feature engineering, what you're trying to do is that you're trying to build features from our test, right? That's the basic understanding behind it. So we're going to build features from our test, right? So we'll be using the simplest format. So the simplest format use TF-IDF, right? You can also use count vectorizer, but I like to use, you can also use count vectorizer. You can also use bag of words as BOG, BOW, as many as you want. But we're using this simple one. So we'll be trying to use TF-ID to help us with that. So let's work on it. So this is going to be our stuff we'll be using. So I just use TF-IDF variable. I'll pass in my TF-IDF from Scikit-MultiLearn, which you already imported above. We'll be using a simple analyzer of word, right? You can also leave without the analyzer, right? It's automatically going to use the default one. So if I run it like this and I check it out through TF-IDF, so it's going to use the default stuff, right? So these are all the defaults. So the analyzer is word, binary is false, then the stop words is none because we have already removed our stop words, and then we can also do some other stuff. So this is the default ones. Now we're trying to fit our build features from it, from our data set. So in that case, we're going to be going with my S features. Let's call it as S features, right? You can give it any name that you want, but let's call it as my S, right? Let's use S features to help us with that. Then I'll just go with my TF-IDF, right? Dot fit. Then I'll fit transform it my corpus, right? So the corpus is the way that we have. Then I'll convert it to an array. Right? So something simple. So we're going to build features from it perfectly. So we can actually see the features there in case you want to check, but that is going to be another way. So if I go with this feature, it's going to bring an array of numbers there, right? Very nice. So it has converted the entire stuff into test features for us. So you can actually see the entire stuff, but that's going to take another time. So let's move on and then train our data set. So we'll be splitting. You split our data set into test and train, right? So it's going to be something simple. So it'll be S train and then Y S test, as we always do. Then Y train, Y test. I'll use my train test split function from model selection. Then I'll pass in my S features. Then we need to pass in our label. So let's set our label. So the label is going to be this one. So based on our data set, this is a multi-label classification, right? So if I check this one here, realize that we have 3 different labels here, right? We have Python, PHP, and then MySQL, and all of them have numbers, so we don't need to encode them. It's already encoded for us. So I'm going to take these ones 1, 2, 3 as my Y label, right? As my label, right? So in this case, our label is going to be a multi-labeled Y. So I'll just go with df.columns to get those columns there, and I'll pick these ones, right? This is a simple way of doing it. I'm picking this one. This is simple for me. Then I'll just go with my flow of this Y, which is going to be my df, pasting this, right? So that is something very simple. So these are going to be our labels. They are already in numbers, so we don't need to encode them again. So Y. Then I'll set the test size. So test size. I'm going to set the test size for that particular training, how much I want to train it to be. So let's go with 0.3, right? That is 30, 70. Then a random state random state of 42 to give us 42 constant stuff. So hopefully everything is working well. So if I go back and I check it again, if I check it here, the shape of this, so let's check for the shape of the first one. So print our S features, right? We are going to check for the shape of the first one, which was my df, right, for the title. That's the first shape. Then let's try the other one. So print for the S string. So this is going to be my S string. Can spell S string dot shape, right? So if I check it out, you can see that now it has used, this is 144 and this is 100, right? That's taking about 44 from it. Very nice. Now let's move on and then do something simple with this. So we'll be trying to build our model. So the first thing, this is building our model. We have finished it, building our features. So now let's build our model. So the basic step is the basic step is that you're going to be using the first stuff, right? You still use the normal models, our normal estimators that we have been using, right? Normal estimators plus our multi-learn algorithms, right? Multi-learn, the multi-label, right? Multi-label, I can't spell estimators. So these are basic stuff that we'll be using. So we're using the normal estimator that we have, like naive Bayes, logistic regression, decision tree, plus this one. That is the basic understanding behind working with multi-label classification, right? So let's see how to do that. So we'll be checking the binary classification problem. This is going to be problem transformation, right? So we are using the problem transformation option. So if I go back to, let's say, import Skmultilearn, if I import it and I check it out, so DRL Skmultilearn, if you check it out, it's having several groups. So we have one for problem transformation, right? So in case you want to use problem transformation, as we learned earlier on, in which you are going to use either a binary relevance, you are going to use either label power set, or you are going to use classifier chains. So it can be found inside the problem transformation. We also have the adapt, which is going to be for the adaptive algorithm like KNN, right? Modify KNN to help us with that. So that is a basic understanding. So let's use the first one, problem transformation, to solve our problem. So we are going to first convert our multi-label problem to a multi-class, right? That is the basic understanding. We are transforming it to a multi-class, but the first one is converting it to a single class. So this is going to be binary classification problem. Right, so let's try it out. So we already imported the binary relevance from above in the previous session here. In the beginning of the video, right, we imported it from here. So these are the ones we are trying to use. So we imported binary relevance, classifier chains, and label power set. So that's what we're trying to use. So we build our first model, then we check it out, right? You create a simple function to make it easy for us. So let's build it out. So I'm just going to go to my bin relevance CLF, right? Let's go to CLF, right, to make it save us. Then I'm just going to pass that binary relevance class. As I said, this is your estimator. So in case you are using multinomial classifier, right, from naive Bayes, that one, then you are passing it with binary relevance, right? So it's going to understand that it's using this particular approach, right? It's combining the multi-label estimator plus our normal machine learning model estimators or algorithms. That's the first thing. Then I'm going to build the same thing I do all the time. I'm going to fit them together, right? So it's going to be my bin to do our training. So binary dot fit. Then I'll pass in my S train and then my Y train. So S train and then my Y train, right? As we always do. I'm going to analyze it and then build relation between them, identify the patterns, and now I can actually make some predictions. So let's make some predictions. I'm trying to see how to make a simple prediction of what we have. So we're going to test it to see how accurate our model is. So I can just call this bin. Let's go to BR prediction, right? Then I'll just go straight away with the S test, right? You're going to test our model whether it's actually making sense. So it's going to be my binary relevance classifier, right? then I'll pass in predict my S test. Oh, did I say S test? My Y test. Right, so I'll just check it on the test data, and then it's going to give us a result. So if I check it back again, so BR prediction, it's going to give us an array of, it's supposed to be prediction, an array of all the various, or a matrix, right, of all the numbers, and how it's going to classify them perfectly. Right, so it's going to give us a sparse matrix, right? So in this particular option, right, you may be thinking, wow, what am I going to do to help me see the result, right? So to see the result of this, right, to see the result of that particular classification, you can actually convert it to an array, right? So let's see. So convert to an array. I can't spell it. You have to convert it to see the result. So in that case, my BR prediction to array, right? So that you'll be able to see it as an array, a numpy array, right? It's going to move it from sparse to numpy array, right? So this is how it is. This is how it's given, and you can see that it's given us the classification as 3 different labels. So 1, 0, 1, and then based on what we had here initially for our columns, we can see that from our columns that we have MySQL as 1, Python as 2, and then PHP as 0. So that is a basic understanding. So every test you're going to supply is going to give 3 different labels, right? So that is a basic understanding. So all you do is that you just do the same thing that you have been doing all the time, but you're going to be using Skmultilearn. You pass your model, right? So this is a basic one you have done. You pass your model, then you fit it. But this time you are passing the Sklearn multi-label problem class estimator around your model. Then you are going to train it. Then you're going to predict, right? Then to get your result, you just convert it from a sparse array to a numpy array, right? Very simple. That is how to do that. So let's check the accuracy of our model. We're checking for the accuracy of our model. So in case you have not, I can't spell nowadays. Let's check for the accuracy of our model. It's going to be for accuracy of our model. And in checking for the accuracy of model, let's see something. So it's going to be my accuracy score. So I'm using an accuracy score from Sklearn.metrics. Now passing my values. I'm passing my Y test. I'm comparing it again, my Y test, and then my BR predictions that we have. Perfect. So if I check it out, it's going to give us a very high accuracy, right? 0.90. Wow, that means that it was able to train very well and give us a very good and high accuracy. But that is not the most important thing. In multi-label classification, you also have to check the incorrect ones, right? So we'll be using the Hamming laws. So we'll be using the Hamming laws to help us know the incorrect ones, right? Which is very interesting. So we use the Hamming laws to help us to check for incorrect predictions, right? Which is very useful, right? So in checking that, the lower result, right, the better. So if the number is lower, that means that it's better, right? That means that it is able to predict most of them correct, and the ones that is able to predict it as not correct, the incorrect ones are low, right? That means that it's having a very good score. Perfect. So that is the Hamming laws, right? So the Hamming laws is very useful. So let's check it out. So I'll just copy this one here because it's the same thing. The only thing we are going to change is just the accuracy score. So I just change it from here to Hamming laws. So the lower the number, the better it is. So Hamming laws, right? Because it's telling us how many of them it was able to predict incorrectly, right? So that means that if it's low, that means that it is able to predict most of the time correct ones. Very nice, right? So that is how to do multi-label test classification using the first method of problem transformation, binary relevance. So I'll build a simple function to help us test on the various different aspects. So we'll be trying to check on the classifier chains approach, in which you're trying to chain them, right? Chain classifiers one after the other, and this one help us to preserve label correlation, right? So that is the next one. Then later we'll move on to the third one, which is going to be my label power set. So label power set, in which you're trying to can't spell. You're going to transform the entire stuff into unique classes, and then you're going to work on it. So I've built a simple function to help us with that. So this is going to be our simple function to save us time, right? It's the same thing, right? The same thing. The only thing we are changing is we are changing the estimator, right? The multi-labeled estimator that we are using. So this is a simple function. We are going to pass in our model, right? A normal model that we have, or estimator. We're going to pass in our multi-label estimator, our S train, Y train, S test, Y test. Then we are going to build our model and train them on our testing data. Then going to make some predictions. Then going to check for the accuracy score, the Hamming loss for each and every of the models, right? So that is something simple. So I made a mistake here, so let's correct it here. So we're using this particular model to help us with this simple function. So let's check it out. So it's going to be my build the model. So let's call it as my classifier chain. So classifier chain, right? Or we can just make it as classifier CLF chain model, right? Then I'll pass in my build model function that we have above. So this build model function is the simple one we had above here, right? Then going to pass in our model, our estimator, our Y train, and our S train. So let's pass in our model we are using. So let's use a simple naive multinomial classification, multinomial, right? Naive Bayes. So we pass in that one first, like this. Then I'll pass in my classifier chain. So I'll pass in our classifier chain, multi-label estimator. Then I'll pass in my S test, my Y test, and the rest, just as we always do here, right? So I'll pass in these ones here, copy this one to save us time, just to understand the basic concept behind it. So this is going to be S, this is going to be Y, and then this is going to be S test capital, right? So let's check it out, right? So let's build it. We're going to build it now. We can now check for the result. So I go back and I check for the classifier chain model for naive Bayes. You can see that this one gave us an accuracy of 0.84, not that bad. The Hamming score was 0.1. That means that it's very good, right? It's actually be able to predict well. So we have built simple two models, one for the binary relevance. We have built another one for the classifier chain. Let's try it for the label power set, right? So the only thing we are changing is just the multi-labeled estimator, right? Apologies for the noise you are hearing behind. So in case you have not subscribed to the channel, you can also subscribe and check the link below for more, right? So I just pass in my label power set here. So label power set class, then let's check it out. So this is going to be my label power set. So CLF label power, right? Label P, let's go to label P for short. So if I check it back again, we can compare the different results given to us. So based on what you have done so far, it looks like the label power set gave us a very high, almost the same thing like the one that we had above, right? Almost the same thing like the binary relevance. So that is the basic understanding behind multi-label test classification using the problem transformation approach. Very simple. Now let's apply this start that you have done on an actual test, right? So be applying it on an actual title. So apply on a simple, right, tag, right? You'll be applying it on a simple title or question, right? Anyhow we call it in SO. It's like a Stack Overflow question. So I'll just pick the first one. Let's pick a simple question. So let's go with my df.title or df title .log. Let's pick the first one, .ilog. I'm picking the first one. This is, as we already know, this is what Flask, right? We know that Flask is Python, we know that it's SQL, and then we know that it's Python. So let's check it out and see whether we'll be able to use this one to help us predict. So to predict, you have to first of all vectorize and then vectorize, right? So we'll be using TF-ID to help us with that. So I'll just call it as my vec test, right? So let's call that vec example, vectorize example. Then I'll pass in my TF-IDF dot transform. So transform is my example that we have, this one. So let's save this one as example 1. I'll transform this one here, this sentence that we had. Example 1 to array, right? I'm going to vectorize and convert it to an array. Then I'm going to make our predictions on it. It's giving us an error because we're not supposed to convert it to an array. It's just supposed to go straight away to this. Right, so let's convert it to a list first. So let's put it inside a list, right? Then also, we don't need to convert it to an array. We can just work straight away with that. Now let's make our prediction. On a single sample, so it's going to be my binary relevance model, right? Dot predict. Then I'll pass in my vectorized array. So if I pass it like this, it's going to give us a sparse array, just as we had. But to get the result, just go with to array. So I go into array, it's going to convert it from sparse matrix to numpy array. And this is actually true. So the first one, we knew that the first one is MySQL, right? The second one was Python, and the third one was PHP, right? Very cool and very nice. So that is how to do multi-label test classification using Scikit-MultiLearn. Very simple, very nice. You can also try it on a different algorithm for the adaptive and see how it works. So to recap, the basic way we can work with multi-label classification problem is to either transform them, right, or use an adaptive algorithm, or use an ensemble approach. So thank you for watching this tutorial. In case you have any question or contribution, you can just put it inside the questions below, comment section below. And please don't forget to subscribe. See you another time. Stay blessed. Bye. But before we go, let's do for the adaptive, right, to save us time. Apologies. Adapted algorithm. So adapted algorithm, I'm using a simple KNN. It's going to be from Skmultilearn dot adapt. Import. There are several of them, but we'll be importing the simple KNN to help us with that. Import KM, right? We are importing the ML, this one. So we have several of them. We have alarm, MLKNN. That's what you're trying to use. And then we just do the same thing that we did above, right? So I can just use the same model to build. So build model. So let me copy that one to save us time. Right, so let's move on and start from scratch. So it's going to be something very simple. So let's go to my MLKNN, right? So it's going to be my MLKNN classifier. Then I can specify the particular K, right? Just like normal KNN. But let's move on with the default. Then I just go straight away with my MLKNN.fit. We fit our S train and then our Y train. Right, to build the model, right? Very simple. It's giving us an error, so let's check it out and fix it out, right? It is giving us an error, so in another session, in another video, we'll try and see how to work on that, right? So thank you for watching this tutorial. So in short, we have seen how to transform a simple problem, right, and then solve it within problem transformation. In another video, we try and see how to work with this particular option, which is failing for us for now. So thank you for watching. See you another time. Stay blessed. Bye.